Good morning, good afternoon, or good evening, wherever you are located, and Happy New Year. Happy 2024 to everybody that's out there. Thank you very much for joining us for the first AMETEK webinar, AMETEK SCI webinar of 2024. And today we're going to be discussing how to connect your UPS in the plant when it gets there, and also some other stuff, including high resistance grounds, replacing lead acid batteries with lithium ion batteries and some other stuff. So what I would like to do, as always, first things first, is rather than me just speak to myself, I'm going to ask if everybody can hear me. If you can hear me, please type in the chat bar on the right-hand side that you can hear me. I'll just wait until I get some answers before I continue. Okay, good day. Thanks everyone for letting me know that you can hear me loud and clear. So my name is Craig Williams. I'm the Senior Technical Manager for AMETEK Solidstate Controls, based out of the Stafford office, just south of Houston, Texas. I have 23 years of experience in the industrial UPS market. I've worked with all of the major UPS charger manufacturers. So I'm pretty good on most systems. Some would like to call me a subject matter expert. There will be a lag of around 30 seconds between you hearing my voice and me seeing a question. Basically, Webinar Jam is the platform that we use to do the webinars. It's got to take everything that I do and then transmit it into iOS, Android, Windows-based systems, so there is some processing time that needs to be done, and it's usually around about 15 seconds from when I speak to actually when you hear me. So if I say something and you have a question, then I'm not going to say it until about 15 seconds later. So for that reason, I ask that if you have any questions, if you could type them into the Q&A bar. So if you see in the chat bar, there is two tabs at the top. One is called chat, and one is called Q&A only. If you have a question specific to what I'm saying, please put it in the Q&A only. And then at the end of the presentation, I will go through all of the questions that have been asked and go through them one by one individually. It's just a much easier way to do these things. If I do see a question pop up and it's pertinent to what I'm saying and it seems to be correct in the flow of me discussing something, I will try and answer it, but there's a lot going on my screen, so I don't tend to have the time to do that. Webinar Jam has a panic button, so if for some reason I start to see posts in the chat that says that you can't hear me anymore or you can't see the screen or something's going wrong, I'll check a couple of things, and then if I have to reboot, then all I do is press a button in Webinar Jam, and it generates a new webinar room. Everybody will be transferred to that room, and we will just continue from where we left off. A very popular question is, will the webinar be recorded? And yes, the webinar is recorded. It's recorded by Webinar Jam as part of the service that they provide. That recording is a bit clunky because what it does is it treats it as a new webinar. So you will get a link to it if you have registered for this webinar. And if you go to that link and press play, it kind of treats it like a brand new webinar. So you can't fast forward, rewind, and pause. There's just not very much you can do. You can just watch it like a webinar. So what our fantastic marketing department do, and London has put a link in the chat bar there, they take that video, they convert it to an MP4, put it on our YouTube site. It takes usually 24 hours to do that. And you can then share that webinar. You can link to it. You can do whatever you want. It is just a YouTube video that's open to the public. You can share it as ever much you want. And you can play, rewind, fast forward, do all that good stuff. And the last question is, sorry, the last statement is, the webinar usually lasts about an hour. Obviously, it depends how much I talk. and I do talk a lot. And also, it depends how many questions that we get at the end. I never cut the webinar short. If there are questions, I will continue asking them until all the questions are answered. So hopefully that explains all that stuff. So as I mentioned right at the top, we're going to understand how to connect AMETEK SCI UPS systems in the field. We're going to discuss the alarm connections, normally open, normally closed, energized and de-energized, and how to connect the alarms on our systems to your DCS systems. We are going to discuss a little bit about systems that have a high resistance ground network, and also a little bit about replacing lead acid batteries with lithium ion batteries. And these are all subjects that have been asked for in previous webinar surveys that we have had. So just trying to go over some of the things that people have been asking for. So here is a very good one-line diagram of one of what's called our microfarad UPSs, or our SE UPSs, okay? And the important thing about this is the input, the DC or the battery connection, the bypass connection, and the AC output connection, okay? Now, as an engineer, if you are an engineer out there that's ordering one of our systems, obviously you have to know how to connect that into your MCC, what cable sizes to use, and all that good stuff. This is the sheet in the drawings that will give you all of that information. So you can see here that the input current is rated right there. So basically, you would have to look at that current and size your cables accordingly, and then size your upstream breaker accordingly. And do remember, for the AC input to any of our industrial systems, you can see here we have A phase, B phase, and C phase. We do not run a neutral. We do not need, and in truth, there is nowhere to land a neutral. So it is 3-wire and ground that you will run to our UPS for the AC input to the battery charger. Okay, that's very important, because if you do run a neutral, you're just going to be running an additional wire. There's additional cost to that, and it's just going to be left disconnected, because there is nowhere inside the system that you can actually connect a neutral to. So when you run the AC input to our UPSs, it is just 3-wire and ground that you run. We do not use a neutral. The input transformer to our charger is delta connected. Okay. Now for our DC connection, obviously it says here that this system here, and it will depend on what kVA size your system is, that the max current that you're going to see is 112 amps. So you have to size your cables to handle at least 112 amps. And obviously, if you're running it in cable tray conduit, you've got to do all the calculations to work out what the best size of cable is for that particular current. But that is the maximum that the system will see. And basically, that's at the lowest voltage. That's at the low battery disconnect voltage. So that is 112 amps is the max current the battery should see. And do remember, we have a positive and we have a negative. I know it seems the most basic things to say that they should be connected correctly, but over and over again, we go out to do startups in the field and we discover that somebody has connected reverse polarity, the battery, to the UPS charging system, and it causes all sorts of issues. So please don't do that. Now the bypass input source, obviously on this system here, because the AC output is 120 volts, then the bypass input voltage has to be 120 volts. Okay, and in truth, 9 times out of 10, this is always going to come from a transformer, and that transformer is going to be a 480 primary. I can't put in the 0 there, sorry, to a 120 volt secondary. Okay, and we do have a ground connection here, so you're going to run 2-wire and ground. 15 is going to be the neutral, 110 is going to be the hot, and the current is going to be 83.3 amps for this particular system, which is a 10 kVA system. So you have to pay attention to what this current is to size your cables from your bypass supply. And then also the AC output is going to be pretty much identical to the bypass input. It's also going to be 83.3 amps, and there are hot, neutral, and ground connections there as well. Okay. Now, the next question that most people ask is, well, okay, what are the terminations inside your UPS? So once again, in our drawing package, you will find exactly what the connections are. And for the Microferro SE systems, this is the page that will show you it. So you can see this drawing here. This shows you all of the connections for the system. Obviously, that's not very good resolution. So this is a blown up version of those connections. And you can see, once again, we've got A phase, B phase, and C phase. And you can see at the top here what the hole sizing is. And because there are two holes, we also tell you what the gap between the two holes are, so you can use two hole lugs if that's what you want to do. So on this one here, it's 3/4 of an inch spacing for the hole spaces. Okay. And the hole size is 0.281 inch. So you can size your lugs according to that spacing. Now that's for the AC input to the charger. You can see here on the output and the bypass of the system, that is different. The hole size is 0.406 inches and the hole spacing is 1 inch. Okay. So if you were going to put a lug on here that has two holes, the hole spacing is going to be 1 inch and the hole size is 0.406 inches. And that's the same for the bypass input, the neutral, and the AC output. Okay. And for the alarm connections for the Microferro system, this is terminal connection number 2. And it says here, the alarm connections, the max wire size is 12 AWG. So the biggest wire that you can fit into these terminations here is 12 AWG. You can run smaller wire sizes. You can go to 14 or 16 because it's a screw terminal. But the maximum wire size for that screw terminal is 12 AWG. Okay. So hopefully that explains those connections so far. Now this system here is our DPP system, which is our digital process power UPS, our more modern UPS. It is the PWM, the pulse width modulated UPS. Once again, this is the general arrangement for this particular customer. Obviously, that resolution wasn't fantastic, so I blew it up for you here. And once again, it is important to understand all of our systems do not have a neutral for the AC input to the charger. So once again, do not run a neutral even for the DPP UPSs. It is not required and there is nowhere to land it. Okay. Once again, for this system, this is a much bigger kVA size system. So now the battery input cable has to be able to handle at least 350 amps. So you're getting into either very big cables or you have to run cables in parallel for this particular connection. Okay. You can see here that the customer has actually done quite a good thing here. He's connected a disconnect where they can connect a load bank to the system to do a load test. And they've also got an external battery disconnect that gives us a disconnect between the battery and the UPS itself. So that is the ideal situation, because that allows us, isolation between the battery and the UPS terminals itself. Because if you didn't have this disconnect and you just connected the battery at this point here, then there would always be battery power at 32 and 31 inside the system. So if you install an external disconnect switch, that allows you to open it, lock out, tag out, and then therefore you can make these terminals here volt free to either replace a UPS or to do maintenance safely. Okay, so that's a very, very good thing to do, is to have an external disconnect from the UPS. Once again, our output is listed here, and you can see that it's 333.3 amps. Well, actually, that's not the output, that's the bypass, my apologies. But the output of the system is identical. You can see it here, 333 amps. So you would have to run cable and obviously take into consideration conduit. Is it in cable tray, and how long the cable run is between the UPS system and the distribution panel to account for voltage drop as well. But that is where you will find the currents there. Okay, 333.3 amps, and we always list it at 0.8 power factor because that is the industry standard. And I mentioned previously that in many systems, the bypass supply is going to be fed from a transformer. And this drawing here, it actually includes a picture of the transformer. And as I said, it's usually going to be 480 volts from an MCC. And it says here it's 104.2 amps. But the secondary is going to be 120 volts and is going to be able to supply 333.3 amps. So obviously the cable on the secondary side into the bypass switch is going to have to be rated for at least 333.3 amps. I don't know if this is a good time to go into it, but I will because it's on the screen here, so it is best to do it. Some people forget that a UPS is a separately derived system. Just like a generator is a separately derived system. In other words, it's creating a new electrical supply, and therefore you have to decide how the neutral and ground is connected. It's a new supply, so you have to decide where you are going to connect the neutral to ground. The recommendation always is that the neutral on the secondary of the transformer is tied to ground at the bypass transformer. That is the industry standard. And if you do that, then you have to remember this wording here. It says remove jumper wire if neutral is grounded at the bypass source. So you would lift that jumper within the UPS itself to disconnect the neutral from ground. Because remember, whenever you have a new separately derived source, you cannot have the neutral connected at 2 points to ground. It's only 1 point, and the best way is to do it at the bypass transformer. Now, there is another place to do it. You can actually do it within the RMBS, because what you've got to decide is which part of the system is less likely to be replaced, because the main decision-making factor when you connect the neutral to ground is you want it at a place where you're never going to have to lift that neutral. So what's going to be replaced more often? Is it going to be an RMBS or is it going to be a bypass transformer? That's a 50-50 shout. I can't tell you which one it's going to be, but some people do choose to connect the neutral to ground within the RMBS. And if you do that, what that allows you to do is you can replace the bypass transformer, and you still have this neutral connection to ground in the RMBS, or you can disconnect the UPS and replace that, and you will still have the neutral to ground connection. So you're not breaking the neutral to ground connection if you replace the transformer or the UPS if you connect the neutral to ground inside the RMBS. Obviously, the only issue with that is if you do replace the RMBS, then you are going to have to break that neutral to ground connection. So the most common, like I said, the most common connection point is at the bypass transformer. And if you do that, you must lift the jumper wire that connects neutral to ground inside the UPS. Okay, so now we're going to show you where the terminations are within the DPP UPS. Now, previously in the microfarad UPS, it was down the bottom of the UPS on a terminal strip that was designed specifically for you to connect your external cables to. With the DPP UPS, it shows here, this is where the customer connections are. And as always, that's not a very clear picture. So I blew it up for you so you can see it a little bit better. So the customer alarm connections are inside the UPS on the top right-hand side of the cabinet. The customer connections 1 to CB1. And if we go to CB1 up there, we can see that that is the AC input breaker. So the connections are actually connected to the input breaker itself. Customer connections number 2 is to CB2. That is the battery input breaker. And customer connections on CB3, that is the bypass. And we're going to go inside the system and show you that in a general arrangement drawing as well. Okay. And the last thing is the alarm connections. Okay, so there are the alarm connections. And once again, I'm going to give you a better picture of that when we get to how to connect the alarms to your DCS system. And there's a blown up picture of it. So you can see on this system here, they had a common alarm, a bypass to load, and a loss of communications. And these are the terminal points that you would connect your cable to. So once again, within your drawing package, this is a sheet that tells you where the customer connections are. So you can see here, that's the battery input. This one here shows the AC input, and this one here shows the bypass input. Obviously, that's kind of small on the screen, so I am going to blow each of those up for you so we can look in a bit more detail as to where those connections are. So for the AC input, you can see that it's actually the terminations are on the, we connect copper stabs, copper bus bars to the terminals on the breaker itself. So you will have to go in behind the breaker and connect your cables to the AC input stabs, as we call them. And you can see that the ratings of those stabs and the hole sizes are listed on this drawing here for the AC input. You can see it. And once again, remember that there is no neutral connected. We only have 3 phases, A, B, and C phase. No neutral is connected at the UPS for the AC input. Okay. And then we have at the bottom here, you can see my terrible circle. You can see where we have the AC output, the system neutral, and the system ground connections. Okay, so for the AC output, we only have a hot connection here because we use this 15, the neutral bus bar, to connect all of our neutrals. That would be your bypass neutral and your AC output neutral. We connect that to the bus bar that is labeled 15. That is our neutral connection inside the UPS for all neutrals. Okay. And once again, you can see that for the hot, for the AC output, that the hole spacing is 5 inches and the hole size is 0.531 inches. So you can choose your lugs accordingly. And the same for the neutral. Okay. Hole size is 0.406 inches. And once again, 1 inch hole spacing. Okay. And previously I mentioned the jumper between neutral and ground. And when you have that bypass transformer grounded, the neutral to ground connection at the bypass transformer, this is the cable that you need to remove. That is the jumper cable that connects inside the UPS, the neutral to ground. You cannot have two neutral to ground connections in any distribution system. So the only one point is going to be at the bypass transformer. Hopefully that makes sense. Now for the battery input, this is where you connect your battery. Once again, it is on the back of circuit breaker 2, the DC input breaker. 31 is the negative and 32 is the positive. And I'm going to say it again. You must connect the correct polarity of the battery to the correct terminals inside this UPS. The positive of the battery goes to positive 32. The negative of the battery goes to negative 31. Okay. And before you ever close this breaker, after you have initially connected the cables, you always want to check. You want to turn on the UPS, turn on the charger, and you want to make sure that you have positive. So this is the output of the charger on the bottom side of the breaker. You're going to have, for a 60 cell system, you're going to have 135 volts there. You want to make sure that you could go across here with a fluke, and you want to make sure there isn't a huge voltage difference between the two. If you see 135 volts between those two positive terminals, then somebody has connected those in reverse polarity. And if you close that breaker, what's going to happen is there's a fuse inside our system and there's a reverse polarity diode usually, and that fuse is going to blow and you won't be able to start up your system correctly. So it's very important to make sure your electrical contractor knows what they're doing when they're connecting the battery to the UPS system. And then for the bypass is connected to CB3. And you can see here they're only listing the hot because the neutral for the bypass goes to that bus bar that was labeled 15 in the previous drawing. So you run the hot cable to this terminal on the back of CB3, which is a bypass input breaker. And once again, the hole size is 0.531 inches and the hole spacing is 1.75 inches. Okay, so you connect directly onto the bus bar that is connected to CB3 within the UPS system. So now we're going to so that was all the power connections. So now we're going to discuss the alarm connections. And the first thing I'm going to discuss is whether you connect it to the normally open terminals or normally closed terminals. Okay, and we try and make it as easy for you as possible because we list for each of the alarms under normal operation. So that is when the UPS is in normal operation with no alarms. We tell you what each of the alarms do. In other words, for the common alarm, which is any alarm in the system whatsoever, it will go to its de-energized state if there is alarms. Okay, and for the bypass to load alarm, it will go to the energized state if it is an alarm. Hopefully that makes sense. As we move on, it should make a bit more sense. So 99.9% of all DCS systems use the fail-safe mechanism. And the question is, well, what is fail-safe? Fail-safe means that is if there is a complete power loss, in other words, everything inside the UPS fails, then you want the alarms to repeat to your DCS system, even if there is no power going to the UPS whatsoever. And not only that, if somebody came along and accidentally cut the cable between the UPS and the DCS system, then you want the DCS system to go into alarm as well. So basically what that says is the DCS system wants a normally open contact. It wants an open contact to alarm for a fail-safe system if it's designed correctly. Okay? So we will bring up our alarm terminal screens again. So that means for the common alarm, okay, in normal operation, we want the system to be sending a closed signal to the DCS system. So in normal operation, the relay is energized. So therefore, these states here will be reversed. So the normally open with respect to common terminal will be closed. Okay, so this will be closed in normal operation. And then only when the UPS goes into alarm, that is now no longer normal operation. So this will go to de-energized. It will change state and it will go to the normally open state. Hopefully that makes sense. And for the bypass to load, it's the opposite. So under normal operation, the relay is de-energized once again. So under normal operation, we want a closed signal going to the DCS. Okay. And then if we have a bypass to load alarm, the relay is going to energize. So it's going to change state, and that's going to change from normally closed. That is now going to go normally open. And your DCS system is looking for an open signal to alarm. So therefore, you would connect common and normally closed for that alarm. Hopefully, that makes sense. Now, another common mistake is when the design engineers order a UPS, some of them will, you can get many different alarms it can repeat to a UPS to your DCS system. I think 24. I think it's 3 relay boards, each with 8 alarms. So you can have 24 alarms, separate alarms, repeating to your DCS system. So the design engineer will go through all of those and he will say, okay, I need a bypass to load alarm separate from the common alarm. I need a loss of communication alarm separate from the common alarm. And they may list 10, 12 alarms separately that go to the DCS system. And then when the UPS gets to the plant and the DCS engineer is involved, he turns around and says, well, I've only got enough room to accept 1 alarm from your UPS system. All the other terminals are full for our DCS system. Now, in that case, the only thing that you should do is connect the common alarm, because for every single other alarm inside the UPS system, the common alarm will operate. So it is a good one-stop shop for the alarms. So if you only have 1 DCS connection available when you connect a UPS, always connect the common alarm. Now, some people, I don't know why they do this. I suppose it makes sense when you're out in the field. If they do only have 1 DCS contact available, some people, what they will do is they will daisy chain these alarms together. So if any one of these alarms comes on, it will repeat back to the DCS system. But as I said before, the common alarm already does that for you inside the UPS. There is absolutely no need to daisy chain any of these alarms. You're not gaining anything by doing that. The reason why we give you separate alarms is if you want separate alarms at your DCS system. It is not so you can daisy chain them all together, and if one of the alarms comes in, it will repeat back to the DCS system. That's what the common alarm does. So hopefully that makes sense. And remember, once again, in the drawing, it will tell you what the terminals accept for these alarms. And I think it's usually, oh, I can't draw up there, it's usually 14 gauge wire. Or less, or smaller, should I say, that you can connect into the alarms. And once again, I did discuss it earlier on. I forgot I had this slide in here. If you do connect the system correctly and you do connect the ground to neutral at the bypass transformer, please do remember to remove this jumper. You cannot have the jumper here and the ground connection here. It can cause circulating currents. It can cause the ground connection to carry current, and the ground connection is not a normal conductor for carrying current. So that is against the code, and please do not do it. Only connect the ground to neutral connection at one place, and that is usually at the bypass transformer. Okay. So now I want to talk about 480 volts systems. So that's a 480 volt system output. So you can see here that the AC output is 480 volts phase to phase, 277 phase to neutral. And there are some systems in Canada and other places where it's 600 volts phase to phase. Okay. It's very, very important at the design stage. The design engineer really needs to pay attention to this at the design stage on why they are doing a 480 volt system. Is it because you have a high resistance ground system, which we're going to go into in just a moment? Or is it because you want to power 480 volt loads from your UPS with some 277 volt loads? You can, and why it's important is the neutral. Okay, on this drawing here, the customer and the AMETEK design engineers know that a neutral is being run to the bypass. And that's very important because the inside of our UPS system needs to have a neutral run. And that's so we can sync monitor things, power supplies. There's a lot of reasons that we need a neutral supply within the UPS system. So if your system is not running on a high resistance ground system, or you are feeding this from a transformer where you can put a neutral on the secondary of the system, then we have the ability to accept that neutral inside the UPS. And if you do this, then this UPS will work absolutely perfectly without any issues whatsoever. Okay. The big problem occurs, and this has happened on numerous occasions, is when this neutral is not run. So in other words, the UPS that was ordered accepts a neutral. So we've got A phase, B phase, and C phase on the bypass and a neutral. But then when the UPS gets installed at the customer's plant, they run a high resistance ground network. They haven't put a transformer between the MCC and the UPS, and they do not have a neutral available. And if you do not have a neutral available, this UPS will not work. okay? There has to be modifications done internal to that UPS if there is no neutral connection run from the plant MCC. It's not as easy as the AC input to the charger, where we only run A, B, and C phases, and we don't need a neutral. In this system, when we have a neutral terminal here, we must have A phase, B phase, C phase, and a neutral run from the MCC or from a transformer. It's absolutely essential the neutral is there. If not, the UPS will not work. Okay? And hopefully the next page will help explain why. So if you're not sure what a high resistance ground system is, a high resistance ground system is where it's actually a floating system. The neutral is not connected, physically tied to ground. What they do is they connect neutral to ground through a resistor network. And that resistor network is designed to limit the current if there is ever a fault between any of the phases and ground. Okay? And the NEC states that you must meet these 4 conditions to be able to run an HRG system. And the benefits of running a high resistance ground system is if you do have a phase to ground fault, all of the systems can continue running without any issues whatsoever. You're supposed to be able to have a ground detector on it so you can find out where that ground fault is and remove the ground fault. So it's for plants that need continuity of power. So the 4 stipulations are: the conditions of maintenance and supervision ensure that only qualified people service the installation. So everybody, any electricians or instrumentation people who work at the plant must know about high resistance ground systems and know that they are working on a high resistance ground system. The second point is that continuity of power is required. So you have systems connected to this power generation system that require continuity of power. You must have ground detectors installed on the system. And then the last one, very important, line to neutral loads aren't served by the MCC. They aren't served by the generating system. Okay? And that's very, very important. So you can see here that this UPS at the design stage, the plant knew that they were going to install this UPS on a high resistance ground system. They knew it was going to be fed directly from the MCC and not through a transformer. So they knew, remember what it says here, line to neutral loads aren't served from the MCC. Okay? So therefore, we don't have a neutral coming from the MCC because that would break the NEC regulations. So you can see all we have for this system here is A phase, B phase, and C phase. We do not run a neutral. And if you tell us that at the design stage of the UPS system, what we will do is internal to the transformer, internal to the UPS, we will add this transformer here that creates a Y connection. It creates a neutral point within the UPS system for us. Okay? So if we know that your UPS is going in a high resistance ground system, we then create the neutral Y point so the UPS operates without any issues. So it's a very important thing to remember. If you're not running a neutral to the UPS, you must tell us so we can install this transformer within the UPS itself. Okay? Hopefully that explains high resistance ground systems. And the last, I think it's the last thing I'm going to discuss today, plan to discuss today. If you have any other questions, and I am open to discussing anything if I know the answers, is replacing lead acid batteries with lithium. It's a hot topic at the moment. Obviously, lithium batteries are gaining a lot of traction in the world and in the industrial backup power market too. So the question that was asked is, when sizing, can you replace lead acid batteries easily with lithium? Okay, and a lot of people, because if you know anything about lithium ion batteries, what they do is they all have a BMS inside it, which is a battery monitoring system. Because for lithium, you need to monitor the voltage of each cell, and you need to try and keep each cell at relatively the same voltage. So there's a lot of stuff that goes on internally, electronically, inside a lithium battery that a lead acid battery doesn't have. A lead acid battery just sits there and gets charged. So a lot of people think, well, you cannot interchange a lead acid battery with a lithium battery. And in fact, that's not the case. The only difference is that any manufacturer who sells in the industrial market knows that battery voltages are usually 120 volts nominal, 240 volts nominal, or 480 volts nominal. Now, there are other nominal voltages, 48 volts, 24 volts, but we're not going to discuss that today. What you have to remember is that lithium cells are charged at a different voltage to lead acid cells. A lead acid cell is classed as a 2-volt nominal cell. So in other words, when a lead acid cell is sitting without anything connected, it is classed as a 2-volt nominal. In truth, if you measured it with a fluke, it's not 2 volts, but it's just for ease. Everybody says that is a 2-volt nominal cell. Therefore, if you have 60 cells in a string, then you have a nominal 120-volt system. And if you know anything about charging batteries, a lead acid battery usually requires 2.25 volts per cell float voltage to maintain a good state of charge. So that means the float voltage will be 135 volts DC. Okay? I hope you're following me here. But for a lithium iron, not a lithium ion, because that encompasses many different ones. For a lithium ion cell, iron, should I say, it has a nominal voltage of 3.2 volts per cell, which means most systems will have around about 38 cells inside the system. The fully charged voltage of a lithium ion cell is 3.6 volts DC. So if you multiply 3.6 times 38, that gives you an overall float voltage of 136.8 volts. Okay, and when you go back to the first line on this presentation, it says really all that you need to know when designing a battery is the charge voltage, the charge current, and the time required, the backup time required. So for the voltage, the difference between a lead acid battery and a lithium battery, a lithium iron battery, is only basically 1.8 volts for 120 volt for a 60 cell system compared to a 38 cell lithium ion battery. So all you would have to do in that circumstance is just slightly increase the voltage. So in most cases, a correctly sized lithium battery can be easily connected to a standard AMETEK UPS or charger with only minor changes to the float voltage and maybe some other voltage related set points such as low DC, DC disconnect, and you would have to go to the manufacturer's discharge curve to get a better idea of where those set points should be. And what my point is, it is not necessary for the systems to communicate with each other. There doesn't need to be any kind of Ethernet connection, or the systems don't need to talk to each other. A lead acid battery does not talk to the UPS, and a lithium battery does not need to talk to a UPS. Now, there are some benefits of a lithium battery BMS system talking to the charger that is charging it. So within AMETEK, we do have systems that are designed that will work with SAFT lithium ion batteries in particular, because we had a project where we had a client who wanted the UPS to repeat all of the alarms from the SAFT battery. And what it also gives us is the added extra of being able to recharge the battery quicker using a higher voltage and current. So because the BMS is a relatively complex piece of software, it can communicate with the UPS if it is designed correctly and say, hey, wait a minute, I've been discharged. I can accept a much higher voltage current to get me back up to float voltage quicker. A lead acid battery can't do that, obviously. There's no communication. So there are some systems where it is beneficial if you want to recharge the battery quicker because it has the ability to accept higher voltage and current, that the UPS talks to that battery. But you must understand that it's a very complex communication system, and it's not, my statement here is that AMETEK SCI UPSs, the DPP UPSs, can be designed to work with a SAFT lithium ion battery because we got with SAFT and we shared our software together. If it was any other lithium ion battery, we would have to go back to the drawing board and we would have to work out how to work our software and their software together. So a very long answer, but the short form answer is, if you want to, if your lead acid battery is getting to the end of its life and you are interested in replacing it with a lithium battery, near enough all the lithium manufacturers have designed their systems so you can plug and play. You can tell them that you are wanting to replace a 120 volt nominal ampere hour lead acid battery that has 3 hours backup time with a lithium battery. They will size that for you, and you can just plug the positive and negative cables into our UPS and it will work without any issues whatsoever. Hopefully that gave you a better understanding of replacing lead acid cells with lithium. And that is the end of our presentation today. So let me see what questions we have. Okay. So I am into the Q&A section. The first question is bypass input always dependent on output rating for all UPS systems? And the answer to that question is yes. The bypass is always identical to the output, because what happens is, internal to the UPS at the static switch, we must be able to transfer to the bypass supply without any break in power. So what the UPS has to do is it has to match the inverter voltage, frequency, and phase displacement with the bypass. So therefore, if you have a 208 volt three-phase system, a 208 120 volt system output, then your bypass must be 208 volt 120 into that system. They must be matched. Okay, so hopefully that answers your question. Whatever the output of your system is, if it's single phase 120 volts, then your bypass must be single phase 120 volts. If it is phase to phase 240, then you must have a phase to phase 240 bypass input. If it is a 480 volt three phase output, then your bypass must be 480 volts three phase. It has to be identical, bypass to output. Hopefully that explains the answer to your question. It says also in the first block diagram why we're not representing ground symbolically, although we are grounding the input. Because we don't know what you're doing, what your codes are, what your system requirements are. Now, obviously, we have a ground connection inside the UPS, and therefore that ground connection should be used for bonding. So you need to bond your conduit, your cable trays, your machine-to-machine bonding must be done through the ground terminal inside the UPS. The neutral to ground connection, as I mentioned before, that is done external to the system, or it should be done external to the system. So once again, that is down to the electrical engineer knowing that we do have the bonding connection inside the UPS, and that is where you bond your external ground to. Also, could you please clarify in regard to the absence of a neutral at the input to the UPS? The nominal electrical power supply is 3-phase 4-wire system with a separate neutral and ground wire. That's not necessarily the case, no. If there are many motors that are just delta connections, anything that has a delta transformer does not have a neutral connection. So the input to our UPS, the AC input, goes into a delta transformer, and that is all we require: A phase, B phase, and C phase. That delta transformer does create a Y inside the UPS, but it's separately derived. It is isolated from the MCC that feeds the AC input to the UPS. So you only need a 3-wire and ground cable going to the system, and there are many MCCs that don't run. You don't require a neutral, or if you have a bucket at the MCC that has a neutral, you don't need to run that neutral. You just run the 3-phase and a ground wire. It's actually more common than you think. And how do we know if the end user is being supplied by an HRG system? Yes, you are supposed to always ask that question at the design stage. One of the first questions, if you are an EPC, or if you are an engineer who is designing a UPS for a plant that you've never been to before, one of the first questions that you need to ask is, do you have a high resistance ground system? And are you intending to feed the UPS directly from the MCC, or are you going to install a transformer between the MCC and the UPS, which you can then create a neutral on the secondary of the transformer from? Okay. So you need to know what the design principle of the system is going to be for the bypass supply. A question: can I install a lithium battery in a nuclear power plant? That's a very good question, and unfortunately, I do not have the skill nor the expertise to answer that question. I don't know if the NRC, the Nuclear Regulating Committee, has approved lithium batteries inside safety-related nuclear power plants. I am sure that I can get our nuclear engineering department to look into that for you and answer that question. But at this moment in time, I do not have the skills necessary to answer that. All I can say is I don't know of any nuclear power plant in North America that has an AMETEK SCI UPS connected to it that has a lithium battery inside it. So take that for what it is worth. Do we have any other questions? Oh, here we go. What is the difference between high frequency UPSs and low frequency UPSs? Are you meaning, there's two ways that I can take that. AMETEK SCI, we manufacture two types of UPSs. So we have our ferroresonant UPS, and what that UPS does is it creates, the inverter creates its AC by generating a 60 hertz square wave inside the UPS that gets converted into a sine wave. And then our DPP system, our pulse width modulated system, is classed as a high frequency UPS. It uses I think it's 8.5 kilohertz PWM signal to create its sine wave. So if that's what you're talking about, if you're talking about internal to the UPS, the difference is that most modern UPSs are PWM, and that means it will be high frequency, but there is complexities involved in that. There's processors, there is, you're switching IGBTs at 8,500 times a second, every second or every minute of every hour of every day, and every day of every year. And for our systems, we expect our systems to last 20 years. So there is more complexity when you are switching at high frequency. Our low frequency inverters, which is the ferroresonance systems, are much easier control circuits. Many would say much more reliable. Many of our customers call them bulletproof. They run forever. We have systems out there in the plants that are 30, 40, 50 years old still, and they are running absolutely fine as long as they are maintained correctly. So it's a choice. You can have high frequency or low frequency inverters, and it is a choice. High frequency inverters have better THD, total harmonic distortion. They're better at regulating the output. They have tighter specifications. So there are advantages to having a PWM system. It's choice. That's what it comes down to. Hopefully that answered your question. Ali, I don't think I can answer your question on this webinar. I don't have enough information to go into depth. What you should do, and London, our marketing department, is going to put in the chat bar in just a moment our service address, our service telephone number that you can call, and somebody in technical service will be able to get you a better answer for why your regulating transformer has a low voltage on B phase. I cannot, I'd have to look at drawings and many other things to be able to answer that question for you. So unfortunately, I can't answer that today in the webinar. Thank you, London, for putting that in. So I think that is all the questions that we have for the moment. Don't forget, if you have any other questions, you can still type them in the chat bar. Once the webinar is over, I will still get notified that there is a question, and I will try and answer them as expediently as I possibly can. But what I would like to say is thank you once again for taking an hour out of your day to listen to me ramble on about UPS systems. It is something I'm passionate about, so sometimes I do tend to talk too much, and hopefully you understood most of the things that I was talking about today. If you have any questions, you can call us on the toll-free number 1-800-635-7300, and you can be directed to the correct person. We also have our email address there. That's sci.marketing@ametek.com, and they will route the emails to the correct people. Or you can go to our website, solidstatecontrolsinc.com/contact us, and use the contact form to contact us as well. Thank you for putting that in, London. Once again, you will receive a link to the Webinar Jam version of the replay of this webinar that you can watch whenever you want. But you will also, you can also go to YouTube tomorrow, our YouTube channel, Solid State Controls, and all of our previous webinars will be are on the YouTube channel, and this one will be there as of tomorrow. I see one more question that's come in. Ryan's asked, are the UPS drawing packages available online? Whenever you order the UPS, you will get an electronic. I don't think we send paper copies of the manual anymore. The person who buys the UPS will get the electronic PDF manuals to distribute to whoever they want. So you should be able to get all of these connection details when you order one of our UPSs. There's another question coming while I'm saying goodbye. What is the maximum and minimum float voltage on the spec sheet? That depends on the battery and the type of battery that you're connecting, because there's even lead acid batteries. If it's a lead antimony battery, it requires a different float voltage from a lead calcium battery. So you have to definitely pay attention to the battery manufacturer's data sheet to work out what the float voltages should be. So hopefully that answers that question. And I think that is everything. So once again, thank you for watching. You will receive a survey, and most of the questions that I answered today, the reason why I designed the presentation today was based on those surveys, because I think it's question 4 within the survey asks, what would you like us to discuss in the future? So please, if you have time, fill out those surveys, because I read every single one of them. I want to know what you want me to discuss at our next webinars, rather than me just arbitrarily choosing a subject. I'd much more like to do something that somebody has asked for. So please take the time to fill out that survey. I really do appreciate you taking the time out and listening to me for the last hour. Watch out for our next webinar, which will happen in February. And once again, Happy New Year to everybody. And I wish you all the best in 2024. Thanks for watching, and take care until next time.